Good morning, Vietnam! Hey, is it a little too early for being that loud? Hey, too late. We're moving on right now.
Good morning, my students, and welcome to another episode of Math and Silly Hats. Today we're going to be identifying outliers and clustering in scatter plots. Before we start, let's make sure we know what outliers and clusters are in terms of a graph of a scatter plot. An outlier is a data point that's far removed from the rest of the data set. So this can be still on the line of best fit, but it has to be very far distant from all the other data points. Clusters are groups of data points with few or no other data points around them. So a cluster would be several data points grouped together that is distant from the rest of the data set. In ALEKS, we'll be asked to identify from a group of graphs which ones have outliers and which ones have clusters. These can overlap, so let's look at one example here. If we're asked to identify all the outliers, let's do that first. So we're looking for single points that are far away from the rest of the data. This graph has effectively no correlation. So all of these dots, though distant from each other, feed into the general pattern of there being no correlation. So none of these will be outliers. In this graph, we have a medium negative correlation, and there is definitely one outlier, a single point of data that's far away from the rest. In this graph, we have a relatively strong correlation again, and one single point far away from the rest. In our final graph, we have a strong positive correlation, save for these two groups. Now they are far away from the data, but they're groups, so those would be clusters, not outliers. When we look for clusters, we're going to be looking for groups of data points with few or no other data points near them. Again, there's no correlation in this graph, so none of these will be clustered as they're all about equally dispersed and have no correlation or trend to follow. In this graph, we have a group of data points here, but they are forming what would be effectively the line of best fit. However, in the lower right, we certainly have a large group of data that is far away from the rest, so that would be a cluster. Here we do have a large group of data in the middle of our graph, but because it's close to other data points, this is not a cluster, even though it is a large group of data. In our final graph, we have clusters in the upper left and lower right, since they are groups of data far away from the rest of the data. Hopefully this has been helpful and that your silly hats stay in position, unlike mine. Have a great day, everybody. Bye-bye!